Hello everyone, I'm the first presenter Jaesuk Choi, and let's start presentation about Lotte World Tower. This is our weekly study plan. It has flow of foundation, structure, construction and skin, and we are now studying about skin part of Lotte World Tower. Last week, we studied about elevators and core wall construction method. After the construction of the surrounding steel structure and deck slab, concrete is placed into slabs and core walls, and the cotton wall is installed. This week, we will introduce about cotton wool. Next, let's take a look at the cotton wool applied to the Lotte World Tower. The cotton wool method is a method in which the outer wall does not support the loads of the building and acts as a curtain. There are three main advantages of this cotton wool method. First, it is lighter than exterior building materials such as concrete, so that reducing the overall wind load and reducing the cost of structure. Second, it can shorten the construction period. Cotton wool exterior material are pre-fabricated material from external factory so that it can be used in parallel with the framing construction. So it can also minimize temporary construction. Third, it improves aesthetic of the building. Since exterior walls are finished using materials such as glass and metal panels, a stylish appearance can be achieved. Lotte World Tower's exterior is 21,000 units in total, and its weight is 600 kilograms. 17,000 cotton walls of different types of units were used. Next, let's take a look at the method of a cotton wall. When constructing a cotton wall in a building like Lotte World Tower, two main methods can be used. First is stick wall method, and second is unit wall method. The stick wall method is a method in which assembling and installing the cotton wool in the construction site. The advantage of this method is that it is possible to modify materials immediately, so it is easy to construct precisely. And the work site in the factory is fast, so the material can be supplied quickly. However, Lotte World Tower is a high-rise building and requires about 21,000 panels. This method was not applied because it takes too long to work on the site. On the other hand, the unit wall method is both glass-mounted and assembled in the factory, and only the installation of complete cotton wool on the site. This video shows the glass mounting and assembling process of a cotton wool in factory. Although it takes a long time to work in the factory, this method was adopted because the work site on the site itself takes less time than the stick wall method. Next, let's take a look at the actual flow of cotton wool construction. When magnifying the construction site of the cotton wool, it is composed as follows. Before starting the construction of the cotton wool, a crane is needed to lift and fix the cotton wool. Spider crane was used in the Lotte World Tower. It is installed on the second to third floor above a floor that work in progress. Then, the unit cotton wool is supplied to the construction floor through a construction lift to the frame. When transporting, several cotton wools are transported while the cotton wools are found through a pallet for material transportation. And before placing the cotton wool, install the bracket and fix it to the wall through the fastener. This video is installing bracket and fastener in the actual cotton wool construction site. Then, Move the cotton wall separately. Operate the spider crane, connect to cotton wall, adjust the position to be desired. This is a video where the cotton wall is lifted and placed at the actual construction site in the Lotte World Tower. And check the level before properly fixing the cotton wall. This is a process in which the bracket or cotton wall measures the inclination and air tightness of fixing the member for precise construction. When the level check is completed, additional fasteners and brackets are installed to completely fix the unit cotton wall. Level check for precise construction. After the level check process, fix the cotton wall. Finally, install the stack joint gasket. The finishing of this part is very important. Precision construction is needed because it is directly linked to water leakage. See this video, you can see the construction precisely considering the water leakage.
I'm next presenter Jo Young-jun. Let's move on to the next topic. This part is about solar reflectivity. Skyscraper designs have extensive exterior glass paneling that may cause hazardous glare to neighboring buildings or nearby traffic. For large projects or iconic structures, it is prudent to evaluate the potential risk of negative effects of solar reflectivity from a proposed design. Examples of problem designs include the Disney Concert Hall in Los Angeles, CA, where curved metal panels reflected intense solar radiation onto an adjacent building facade, and the Buddha Hotel in Las Vegas, MB, was reported in local newspapers to produce a death ray due to intense solar reflections from the concave curtain wall geometry. When the tower was planned, tools to study the effects of solar reflectivity were limited to single ray tracing computations that do not account for accumulation nor for intensity of light. Not only are building codes silent on requirements or limits for reflectivity, but neither is any industry metric available for defining acceptable performance. So the cotton wall consultant CDC developed a method to predict of solar reflectivity. Computational fluid dynamics (CFD) were used to emit a large number of rays and trace their trajectories inside a computational domain. And also proposed design criteria for a threshold of acceptable intensity based on comparison to common source of light in concert with the project environmental conditions. This information would allow the designer to make reasonable judgments regarding needed attenuation of the project glass's optical properties or to the finishes on reflective surfaces. To properly analyze sunlight, one must begin with a heliocentric model of the planet's movement. Next, a project-centric model is needed to begin sun tracking diagrams that illustrate exposure unique to the project location and orientation. Also, the model domain requires some level of accuracy with regards to surrounding environment. Adjacent buildings may shade the project at various times of daylight on certain days of the year. And conversely, roadways or near neighboring facades may be sensitive to reflections bounced from the project's reflective surfaces. They use a Monte Carlo ray tracing technique, which is obtaining the stochastic distribution of the desired figures from the statistics of repeatable experiments to inject sunlight into the model domain. Light is injected as follows and reflects like this. This is reflected ray curtain. This is the reflection rates of the noon time during the year. Only reflection from the project's target was analyzed. Secondary reflection was not included and only specular reflection was analyzed. Due to the enormous amount of data generated by the CFD routines, the studies was needed to be guided by intuitive forecasting of critical days and times. And once hotspots were discovered, then fine-tuning of the times examined could be specifically identified. As a result, the most reflective parts that maximum intensity was buildings across from the lake. As a result, this could be used to determine whether reflected glare is going to be a problem for motorists, pedestrians, and adjacent buildings. This is the role of our team members. Thank you for listening.